Hello students, welcome to Sreenath. In this video, we are going to learn the 13th chapter in the class 6th science. Okay, what is the chapter name? The chapter name is Fun with Magnets. My name is Karthik Nune. We are creating videos for all subjects for CBSE Class 6 to 8 and our videos are 100% free. So please subscribe our channel, also follow on Instagram and join our Telegram channels. Let's begin this video. Now, what is the chapter name? The chapter name is Fun with Magnets. Okay, basically in this chapter, how many topics we are having? We are having 5 topics. So without wasting time, we are going to have an overview of all these 5 topics, and after that we will discuss each topic in detail. Okay, now we will discuss overview. How many topics are there in this chapter? There are 5 topics. What are the 5 topics? The first topic here is the introduction of this chapter, where we observe magnets in our day-to-day life and how magnets were discovered. Okay, until after completing introduction, it is the first topic. We are having the first topic is magnetic and non-magnetic materials. It is the first topic we are having. What is the difference between the magnetic and non-magnetic materials? Basically, what are materials? We know different type of materials, but how we classify based on the magnetic property. Some materials are magnetic properties and some materials are non-magnetic properties. So we called as magnetic materials and some as non-magnetic materials. How we classify this? How these magnets? We are going to learn about this. The next topic, that is the second topic, is poles of a magnet. So basically every magnet has poles. How we will define poles and what are the properties of poles? We are going to learn about this. Okay, now the third topic we are going to discuss is finding directions. How we can find directions using magnets. What is the property behind it, finding magnets? And is there any device developed using the concept of magnets directional property? After that, we are going to discuss about the fourth topic, that is make your own magnet. How to make our own magnet, how to make our own compass. We are going to learn about all makings on this fourth topic. And the last and the most interesting topic, which is having an interesting game, that is the fifth topic. What it is? Fifth topic. Okay students, we are going to discuss all these topics, all these 5 topics in this video. So without wasting time, we are going to start this session. So before starting, we have an introduction about the magnets. Okay, basically if you see in some almaras like that, there or on the doors of refrigerators, there are some magnetic stickers. They will stuck to the doors, and some pencil boxes. If we close it, suppose we have some pencil boxes, when we close it, they will stuck. Even though there is no locking system, they will stuck tightly. So what is there on the box which helping to stuck? And when you see this pin box, what happens when you drop some pins? What happens? Some pins will stuck to the head or the top of this box. So these are the practical real life examples where we observe or where we see magnets or where we use magnets. Okay, how magnets were discovered? Okay, basically the name how magnets were discovered means there is an interesting story. Okay, there is a shepherd. Do you know the shepherd? Do you know shepherds? Yeah, there is one shepherd. He has some goats and sheep. He is feeding those sheep by sending them or to the hill areas, on that areas, so that he is feeding all his goats and sheep. Okay, what is the name of that shepherd? The name of the shepherd is Magnus. Okay, what is he has in one stick? He has one stick. It has at one end it is having iron cap. At one end it is having iron cap. What it is? Iron cap. When he takes his sheep to hill area, and when he is walking with that stick on the stones, what happens? His stick was stuck to one stone. His stick was stuck to one stone, and he is trying to pull it. He tries to pull it from that stone, but it is tightly stick to it, and he applied some more force to drag it, to pull it. So finally he got his stick. So what is the stone which attracts that stick? Basically, that stick has an iron cap at the end, and this iron cap at the end, that iron cap, what happened? That iron cap is stuck to a stone. Why that iron cap is stuck to the stone? There are so many stones around. All these are stones around, but it is stuck to the only one particular stone. Why it is stucking means, then he finally discovered that that is the stone which has magnetic properties and or magnetic material. Basically, this stone has the property of attraction. What is the property called? Attraction, because it is attracting this iron cap. For that reason, the iron cap is stuck to the stone. So finally, magnets were discovered. So on the name of Magnus, he observed this phenomena in nature. He find out a stone which is attracting iron caps or iron things. So that attracting property is for that stone, is or for that rock. So finally that rock has some property, and that type of property exhibiting materials or exhibiting ones we called as magnets. What it is? Magnets. So magnets is the word derived from Magnus. Magnus is a shepherd. When he traveled with his sheep to feed them on an hill area, his stick having iron cap was stuck to the one of the stones here. Like we are having some stickers which is stuck to the iron doors of or to our refrigerators, like that. So the attracting property of attracting iron is called the magnetic property. So that magnets were discovered. On the name of Magnus, they named it as magnets. So in this way, magnets were discovered. What is the property they are having? They are having basically the attracting property. Attracting property. Does the magnets attract everything? No, they are attracting only some type of materials only. We are going to discuss this in later. So basically, magnets were named on the behalf of the Magnus, who is the person, who is the shepherd who discovered the first magnetic attracting property. And what are the different types of magnets? There are so many different types of magnets. These are the artificial magnets. We have prepared them in our factories, but the natural magnet, there are some natural magnets also. The stone with the shepherd encountered is the natural magnet. It also that stone also has a name, some name. We call it as lodestone, like that. They called that stone as lodestone. Okay. Now there are different types of magnets. The one is bar magnet, which is in the shape of bar, and there are horseshoe magnet also. It is like this shape, and there are this type of magnets, and there are cylindrical type magnets, like that. There are so many type of magnets available at present. Okay. Now after completing the introduction, we have entered into the first topic. What is our first topic? The first topic is magnetic and non-magnetic materials. What are the magnetic materials and what are the non-magnetic materials? Okay. Basically, now we will find the definition for magnetic materials. What are the magnetic materials? So the materials which get attracted towards a magnet are called magnetic. Okay. Magnetic materials are nothing but the materials which attracted towards a magnet, towards a magnet are called magnetic materials. So what are magnetic material means? It is very simple. Any materials which are attracted towards a magnet are called magnetic materials. If you want to know clearly about this, take a bar magnet and take some of the objects around you, or take some of the materials around you, and move all those materials near to the magnet. If any material is attracted towards your magnet, then that material we can call as magnetic material. For example, what are the examples? For example, safety pin. Do you have your safety pin? Suppose if you take this safety pin near to your magnet, what happens? The safety pin stuck to your magnet, so it is attracted towards the magnet, so it is called the magnetic material. So safety pin is called the magnetic material. Now take your pencil. Example, now take your pencil or rubber or your plastic box or anything, or your plastic box or plastic bottle. Okay, now take your pencil or anything and move that pencil near to your magnet. Observe what happens. Does your pencil is attracted towards the magnet, or does your rubber is attracted toward the magnet, or does your plastic box is attracted towards the magnet? If you find it, if you observe it, there is no attraction. No pencil or rubber will attract it towards your magnet. Then what are these materials we called as? We call these materials as non-magnetic materials. What are those? Non-magnetic materials. What is the definition of non-magnetic materials? It is very simple. Non-magnetic materials are nothing but the materials. Okay, the materials which not attracted. The keyword in here is not attracted towards a magnet. It's very simple, guys. It's very simple, kids. If suppose any material, you are having any material, if you take that material near to a magnet, if that material is attracted toward the magnet, then that material is called the magnetic material. If that material is not attracted toward the magnet, then that material is called the non-magnetic material. Simply two types of materials. One is magnetic material and the another one is non-magnetic material. Magnetic material is material which attracted towards magnet. Non-magnetic material is the material which does not attract toward the magnets. So just take your safety pin and take near to your magnet. It will be attracted. So like that safety pin, there are find out other things or other materials in your room or in your kitchen or your classroom or your home, wherever the place you can distinguish what are the magnetic materials and what are the non-magnetic materials. Suppose take objects like this: iron ball, scale, shoe, like that. Take and fill this table with different of objects and move and write the material there, with which material they are produced or they are made. Iron ball, it is made with iron. Scale, it is made with plastic. Shoe, it is made with leather. And finally what you have to do, you have to take your magnet near to these objects. If any object is attracted, then that material or then that material with its made is the magnetic material. Then if anyone is not attracted, then we called that materials as the non-magnetic materials. That's it. It is very simple, guys. Okay, now here is another activity. With using a bar magnet, can we find iron separate? Can we separate iron fillings or iron particles, iron fillings in sand? Can you separate iron fillings in sand using a magnet or anything? Yes, we can do it. We can done it by the help of magnet. What it is? By the help of magnet. By the help of magnet, you can easily separate iron fillings. Why? How can we separate? means basically magnet has the property of attracting magnetic materials. It will attract the magnetic materials. So iron is a magnetic material, so it will be attracted toward the magnet. And the sand, it is not the magnetic material, it is the non-magnetic material. It does not attract towards the magnet. So if you take our magnet to the sand, then the iron fillings in the sand will be attracted, collected near to the magnet like this. They will be attached to the attracted towards the magnet like that. And the non-magnetic materials like sand, they will not attracted towards the magnet. If you take out your magnet out of the sand, the iron fillings will get stuck to the magnet and the sand will be present in its previous stage. So in this way you can separate iron fillings from sand easily using magnet. So that's it. We have completed the first topic, guys. First topic, students. Now we have entered into the second topic, that is poles of a magnet. Poles of magnet. Does magnet has poles? What is called poles? Basically, suppose it is the bar magnet we are having. It is a magnet. So it has ends, and it has middle parts. So what are these called? We call these as magnetic ends. We call these as magnetic ends. This is the middle of magnet. Okay, the magnetic ends, we call the magnetic ends. The another name for magnetic ends is nothing but magnetic poles. What it is? Magnetic poles. The magnet ends of a magnet we called as the poles of a magnet. So what is the poles of magnet? Every bar magnet have its end. So we call those ends as the poles. And if you do one experiment, suppose if you take iron fillings or like that on a paper and place a bar magnet in it, what you observe means the maximum number of iron fillings will be get attracted and deposited at the ends like this, at the ends, and only some of the iron fillings will be deposited in the middle. Maximum number of iron fillings will be deposited at the ends, and some of the iron fillings will be deposited in the middle of the magnet. So the end part of the magnets are having more attractive property. The end of the magnets are having the more attractive property. So we named the end parts of the magnets as the poles. So magnetic poles having high attraction or high attractive property. Poles having high attractive property. What are poles? Poles are nothing but the ends of the magnet. So poles, so magnet has two poles. We call it as two poles because it has two ends, no? So that how many poles there we are having? There are two poles, and we are named it as North Pole and South Pole. Basically, for a bar magnet we are having two ends, and we call those ends as poles. And what are those ends? Those ends are named as North Pole and South Pole. Why we have named those as North and South? Basically these two are the ends, no? So those will be same, no? But why not? Why they are not same? Why they are named as different? Why they are treated as different? We are going to learn about this. Basically, poles of a magnet has its ends we called as poles, and those poles are one is North Pole and another one is South Pole. Then which is North Pole and which is South Pole? What is the difference between them? We are going to learn about it. One thing we are learned about it is at the poles have high attractive property. More number of iron fillings are accumulated at the ends, and a very less number of iron fillings are accumulated at the middle of the magnet. Okay, that's it. Okay, now poles of a magnet are said to be near these ends. Try and bring a few magnets of different shapes to the classroom. Check for the location of the poles on these magnets using iron filling. So basically, what are poles means? Where the maximum number of iron fillings are deposited or located, we call those as the poles. Basically, magnet is there is a magnet, it has an ends, and it near to its maximum number of iron filings are accumulated. So we called though the area, the location where the maximum number of iron filings are attracted are called as poles. So basically two types of poles we are having, that is North Pole and South Pole. We are going to discuss how we name those as North and South in the later section. Okay, and what you have to do, you have to take different types of magnets, and you have to check and you have to place those magnets in the path on the iron fillings and find where are the poles for the different types of magnets. Simple one logic is where the number of iron fillings are increased, or the more number of iron fillings are deposited on the magnet, those points are called as the poles. Next, we have completed second topic, we have entered into the third topic. Basically, in the previous section we are discussed about the attractive property of the magnet. Now we are going to discuss the another property of the magnet, finding direction. How we will find the direction? Basically, there are so many stories about magnets because they were discovered long ago. Basically, one emperor in China whose name is Hong Tai, he is having a chariot. It has a toy and it has a stretched arm, and this stretched arm represents the direction. This stretched arm represents the direction. So with the help of this chariot and with this toy, he can easily find the direction. So how this toy is knowing the direction? We are going to crack this question or crack this logic. How this toy, if it is travel to any place, it is telling the direction of north to the emperor. How it is helpful? Now we are going to discuss about it. Before going to crack it, or before going to know it, what is the logic or what is the physics behind it, take one bar magnet and tie with a thread like that, and suspend it from a stand. So make sure that it can freely move. Okay, now and give a push at one end and leave just give a push or like that to rotate, try to rotate it and leave it. Don't make so many revolutions, just push a slight and leave it. What happened? After some time it will settle in one direction. After some time it will settle in one direction. Suppose after some time it is settled in this direction. Note that direction. This is the direction. This is the magnet. The direction is along the magnet's length. This is the length of the magnet, L. Suppose there is the magnet, this is the length of the magnet. Along the length of the magnet, take that direction. Note that direction. Okay, now what you have to do? Now do this experiment in your classroom. Okay, and again repeat this experiment in your home. You have to do this experiment in your home, and you have to do this experiment in your classroom. So before doing this experiment, you have to know that what is the north, south, east, west of your home. What is the north, south, east, west of your home? If you don't know how to find the directions, just see the sun. The sun rising direction is the east direction. Suppose the sun, when you wake up early, the sun is rising from this direction, then from this area, then it is the east direction. Opposite to this, the sun setting direction is the west direction. If the sun rises in this direction to your home, and sun is going and like this, and sun is setting in this direction, then it is the east direction, then it is the west direction. So if these two are the east and west directions, you have to face towards the east, and your left hand gives the north direction, your right hand gives the south direction. In this way you can know what are the directions of your home, or when you are in home, what are the north direction, what are the south direction, and what are the west direction, what are the east direction. In the similar way, you have to find out the directions when you are in the classroom also. Now what you have to do? You have to do this experiment in your home. You have to do this experiment in your classroom. Then what happened, or then you observe what happened means, I will tell what will happen. What happened means, this, what is this? This bar magnet will align in this direction, this bar magnet will align in this direction. Okay, at the same time, this bar in this classroom also, this bar magnet will align in this direction, Why it is align in this direction? What is this direction? This is the north-south direction. This is the north-south direction of your classroom. When you do this experiment in your classroom, what happens? In the classroom, the magnet is aligned in the north and south direction of your classroom. So maybe it might be by accidentally it is showing the north-south direction of your classroom. That's why you repeated this experiment at your home also. And before doing this experiment, you marked the north and south directions in your home. After doing this experiment also, again the bar magnet is aligning towards the north south in your home also. Then you got surprised why it is always showing, always representing the north side south directions. Why it is always representing north south directions? Then what you have to do, you have to mark the one end of the, you have to mark the ends. Basically this is the north side of your home, so the end which is in the north direction, you have to mark it as N, or you have to mark it with some color. Then then your bar magnet is like that. You have marked the one end or one pole. You have marked the one pole of your magnet which is lying in the north direction, Then we called this as north pole. Basically what you have done here, you have marked the pole which is showing north direction in your home, Then that end we called it as, that pole we called it as south pole. Then the opposite pole, basically magnets having two poles, we have previously learned. The opposite pole we called it as the south pole. Why? Because means it is representing the south direction. Whenever you are suspending this magnet, it is showing the south direction. When you suspend it in your home, it is showing the south direction, and at the same time when you suspend this in classroom also, it is again showing the south direction. So that pole is called the south pole. And the one which is showing north direction of your home, when you placed it in your home, is called that pole is called the north pole. So this is the reason we have named the both poles as different names, that is north pole and south pole. Previous topic I have told you, we will discuss later about what is north pole and what is south pole. So simply, what is north pole and what is south pole, can you understand now? Yeah, the pole which is representing the north direction is called the north pole. The pole which is representing the south pole is called south pole. So what finally we have concluded, that when bar magnet is freely suspended, it is showing the direction, or it is aligning in the north south directions. If you mark the north pole in one case, then in further cases you can simply know by doing this experiment, by seeing the alignment of this bar magnet, what is the direction what is the direction of your home or house, or where is the north direction, what is the north direction, what is the south direction. You can simply know by observing the north pole of the magnet. If your north pole is in one direction, that direction is the north direction. By using bar magnets, you can easily find the direction. So finding directions, so how can we find the directions? By using a bar magnet and simply suspending it, it shows the north direction. So basically same logic, same physics, same phenomena the China emperor have used. It has a bar magnet, and the raised alarm is the north pole of the bar magnet. So whenever whatever the place maybe the chariot goes, it is always it has freely suspended. It does not have any agnate forces that such that it is furnished, or such that it is developed, it is built. So that's why the arm showing the north direction. So that's why in that way that chariot is showing the direction to the emperor. So thus chariot is based on the principle of the magnet having the property of direction. We call this property as direction property. What is the property? Direction property. Because of this property we can easily find the directions. Okay, so basing on that property, compass has developed. Basically compass has one box and one plastic and one glass over lid, and it has some needle which is iron needle, and it is magnetized. This needle works as a magnet. Whatever the place you place it, what it shows, the magnet, the needle which acts as a magnet will align in the north south direction. So basically this compass has a dial at the lower part, and there are printed letters about north, south, east, west directions. What you have to do, you have to rotate this magnet such that the magnetic needle must align in the direction of north south, which is printed on the dial. You have to rotate this magnet such that this magnetic needle must align with the printed north south. This magnetic needle must align with the printed north south direction which is printed on the dial. So if the coincidence of this needle with the printed north south of the dial gives the perfect north south directions. Okay, once you know the north and south directions, then you can easily find the east and west directions. So by using this compass you can find the directions. Basically the passengers who are traveling in the sea and on the air will use this compass to know the directions. So we have completed third topic also, students. We have completed it. Now we have entered into the fourth topic. What is the fourth topic? Make your own magnet. How can we make our own magnet? Okay, it is very simple. Take one iron bar like that and take one magnet, and what you have to do, you have to pick up one end, maybe it's a north end or south end, and what you have to do, you have to rub this iron filling. You have to rub this in one direction only. You have to take this this iron piece, and you have to take magnet. What you have to do, you have to rub it in one direction only. You have to rub it like this, and not you're not to and fro motion. You have to rub it like this, and you lift your hand, again rub it like this, and you lift your hand and again rub like this, and you did not rub like this. This you did not rub like this. You always rub in one direction only. You have to rub from this. You have to start from this point, you have to end this from point, and lift your hand and move your hand to this point, and again rub in this direction, and again lift your hand and again rub in this direction. If you continuously rub that iron bar like that, like for 20 times or 30 times, what happened? After some time, remove the bar magnet and take this iron bar and take this iron bar to remaining safety pins like that magnetic materials. What will you observe? You observe that those magnetic materials will be attracted towards this iron bar. Then what happened? This iron bar become magnet. So it has the property, it gets the magnetic properties, so it will attract the magnetic materials. So in this way you can make our own magnet. Okay, and you can also make your own compass. How means, suppose if you take some small needle and you have to magnetize it like that, like in this manner. You have to magnetize that iron needle also. After magnetizing it, what will happen? That iron needle will acts as a magnet. So you have to place that magnet in a foam or on sponge, and you have to freely float it over on a water. And if you turn it like some distance, then what happened? After some time it will settle in one direction. That direction gives the north and south directions. So in this way you can find the compass. You can make your own compass. So we know how. So now we have learned how to make magnet and how to make compass. So that's it. We have completed the fourth topic, students. Now we have entered into the fifth topic. What is the fifth topic? Attraction, repulsion. Attraction and repulsion between magnets. Is there attraction and repulsion between magnets? Yes, obviously. How can we know this? Yeah, by using a simple game we can know this. Suppose take a car B, take a car like this. This is the car A. This is the car A. What happens in car A? Keep the south pole of the magnet towards its front. Suppose this is the car A, this is the front side. This is the front side. Okay, this is the front side. This is the rear side. This is the back side. This is the front side, this is the back side. What you have to do in a car A, what you have to do in the front side, keep the south pole of the magnet towards its front side. In its front side you have to put the south pole, and to the rear side, then automatically it will be north pole. Now what you have to do, you have to take another car B. For that car B, what you have to do, you have to place the magnet in the opposite direction in car B. So in this direction, this is the front side of the car, this is the rear side of the car. In this car, how you have to put your magnet, you have to place your magnet in opposite direction. Basically here we placed south pole in the front side. So here what you have to do, you have to place north pole to the front side and the south pole to the rear side. So finally these two are the cars. Now what you have to do, you have to find out this table. So first table, position of the car. How are the position of the both cars? First thing is front of car A facing the front of car B. So what is the front of car A? This is the front of car A. It is facing the front of car B, which means suppose this is A, first condition, this is A, and this is the front of car A. Now how we have to place the another car? This is the another car B, this is the front of car B. You have to face front of car A facing the front of car B. So front of car A and front of car B must be face each other. What happens in the front of car A? What is the pole we are having? We are having south pole. In the front of car B, what is the pole we are having? We are having north pole. Now what you have to do, you have to take these two cars and move these two cars closer to some distance and try to not touch the both cars. Observe what happens when you take these two cars very near. What happened? You have to observe and write the result here. And the second condition is rear of car A facing front of car B. So first thing is rear of car A. Where car A is this, what is the rear? He is the rear part of car A, which means it is not the rear of car A. So it is the front direction, it is the rear direction. Rear of car A is facing the front of car B. So here this is the car B, it is the front. So what we have to do, rear of car A is facing the front of car B. So in the rear, what is the pole we are having? Rear of car A is having north pole, and front of car B is having north pole. In this condition also, take these two cars very near to each other. What happens? What will you observe? Whether both these cars collide each other, or whether these cars remain in the same position, or whether these cars repel each other and move away from each other. Whether these cars move away from each other or whether these cars move together each other. You have to find your observation. Now what is the next observation? Next observation is car A placed behind the car B. Suppose it is the car B. You have to place the car A. Behind means behind by end of car B. What happens? This is the end, this is the rear end, this is the front end. What is the car B of rear end? Car B of rear end is south pole. Car A of front end is south pole. You have to observe again. Take these two cars very near. What happens? They will collide with each other, or they will move far away from each other. Now rear of car B. This is the car B. Rear of car B facing rear of car A. What you have to do? Again car A is there. Again rear part of the car A. These two must be face each other. So rear of car B is south pole, and rear of car A is the north pole. Now what you have to do? Again you have to take these two cars very near to each other. So in all these four conditions, what will you observe? Does the cars move away, or does the cars move very near to each other? Does the cars collide? In this case, if you do this game, what happens? They will collide each other. What happens? They will collide each other, or which we call it as they will attract also. They will attract each other. They will collide each other. In this case, they will move away each other. We call it also as they will repel each other. In this case also they will repel each other, which means they will move away from each other. In this case they will attract each other, which means they will collide each other. So how can I know without doing this experiment? Means basically from these observations what we have, what are the conclusion we are having, what are the conclusion we are having after doing this experiment, after doing these observations. What are the conclusion is, like poles attract each other, like poles attract each other. This is the very important conclusion, very useful in every subject in your higher studies. And unlike poles repel each other, sorry, like poles repel each other, I am confused sometime. So like poles repel each other and unlike poles attract each other, What does it mean? What does it mean? Like pole means north pole and north pole is a like pole, north pole is a like pole, south pole is a like pole. What are the unlike poles? North pole, south pole is an unlike pole, south pole, north pole is a unlike poles. Basically, if you see in this condition, what happened? North pole, south pole, and these are the unlike poles. These are come together, so they will attract each other, which means unlike poles attract each other. In this case, north pole and north pole, they are moved each other. So north pole means they are like poles. They like poles. What have they have done? They have repel each other. So like poles repel each other. In this case also, both are south poles. So both are like poles. So like poles, what they will do? They will repel each other. So here like poles repel each other. In this case, they are the unlike poles, they attracted, so unlike poles attract each other. So this is the very important conclusion, like poles repel and unlike poles attract. Okay, so that's why we have completed the 4 topics, and there is some few cautious thing about for us. Means magnetic substance, the magnetic nature of a substance will be lost if you heat it, or if you hammer it, or if you drop it. By doing these things, your magnetic nature will be lost. So don't do such things by a magnets, then your magnet lost its magnetic property. Okay, that's it. Okay, we have completed our chapter, students. We have completed our chapter completed. So we have seen keywords. Compass is a device used to find the directions. Magnet, which is named using the Magnus person. Magnet has attracting property. Okay, magnetite, it is a substance which attracts magnets. North pole and south pole. North pole of the magnet, it shows the north direction. South pole of the magnet shows the south direction. We have completed the chapter. Our chapter is completed, students. Now what we have to do? We have to enter into the summary session. What is the summary? Now we are going to have the summary of the whole chapter. So basically, chapter name is Fun with Magnets. It has 5 topics. How magnets were discovered. First thing, it is in the introduction. There is a man shepherd called Magnus. He has a stick which has an iron cup. It was stuck to a stone while he is going while he went onto a hill. So that stone attracted this iron cup. So the Magnus who discovered this attracting property, on the honor of that person, we discovered that nature, that attracting property, or the attracting property showing materials as magnet. So magnet having attracting property. There are so many types of magnets. There are bar magnets, horseshoe magnets, like that. And magnetic materials and non-magnetic materials. The materials which attract towards a magnet are magnetic materials. The materials which are not attracted towards a magnet are non-magnetic materials. The examples for magnetic materials are safety pin and iron fillings, like that. And the example for non-magnetic materials are pencil, rubber, plastic, or like that. The next concept is the poles of a magnet. So every magnet is having it ends and middle part. When you the poles of the place where more iron fillings are attracted are called the poles. So basically, magnet has it ends, iron fillings are attracted more at the ends. So we call those ends as poles of the magnet. So magnet have 2 poles, one is north pole and south pole. Near magnets more number of iron fillings are attracted, or near poles poles are having more attractive property than the middle part of the magnet. So Magnet has both ends. We call both ends as poles, and we are having two poles. One is North Pole and one is South Pole. Why we call those as poles? Why we marked the poles at the ends means the ends are having so much of attracting property than the middle part of the magnet. That's it. That is the attractive property, one of the property of magnets. Next one is the another property, that is the direction property. So magnets can be used to find directions. Basically, when you tie a magnet to a thread and leave suspended, it will align in the direction of north and south directions. So by using magnets, you can easily find north and south directions. So on basing this directional property, magnetic compass were developed. These devices are very useful to find direction when we are traveling in seas or in hills or in any places. So finally, how can we make our own magnets? By rubbing in same direction with a bar magnet, we get our own magnet. And by placing the magnetized needle in a foam in a cup, you can make your own compass also. And what is the fifth topic is attraction and repulsion between magnets. Basically, magnet having two poles, like one is North Pole and the South Pole, and the like poles will repel each other and the unlike poles will attract each other. That's it, students. Our chapter is completed, our summary is also completed. So please like our videos, share our videos, and please don't forget to subscribe our channel, because we are creating all subjects on this platform and those are 100% free. So please subscribe our channel, please like and share comments. Feel free to comment below if you have any doubts. Have a nice day, keep learning, bye bye.